Hello and welcome. Yeah, my name is Schumann. I'm try to talk a little bit about functional safety in CAN-based systems or functional safe communication. Um, yeah, um, I'm working with CAN and CAN automation now for over 25 years and was involved in the standardization of many different related things to CAN and CAN Open, especially also the CAN Open Safety Protocol. And I'm also somehow a little related to uh, the cybersecurity and the stuff what Olaf is working on. But now I want to talk about functional safety. What does functional safety means? Um, at first, functional safety is a requirement in the European Union, which comes from the EU machine regulation. And in the machine regulation, in the most current version, which is the regulation 2023 slash 1230, which became active in 2023 with a period, ongoing period to be in full action in 2027. And in general, it is defined here that functional safety in the context of the EU machinery regulation refers to the safety that depends on the correct functioning of a correct control system. So at first, that means it's nothing complicated. It just means that it depends on the correct functioning of a control system. So basically, you don't have any bugs in there. And we know we don't have bugs in our system, so we are fine, hopefully. Oh, no. So it's basically to cover the problem of that there are maybe failures, bugs, errors, something like that. So that means it is a critical aspect of the EU's health and safety requirements, ensuring that machinery operates safely and poses no hazards to users or the environment. And the regulation then outlines these requirements, emphasizing the importance of risk assessment and the reduction of the risk associated with machinery. The regulation aims to protect both the public and workers by ensuring the machinery meets a high standard of safety before being placed in the European market. So we have some main points here. At first, we have to identify the risk in terms of a risk assessment. And then we have to reduce those risks to protect the users, the public, and basically public and the workers. So we are always talking about machinery, which makes it difficult to pinpoint it to a part of the machinery, because the machine regulation is about the machinery as a whole. And we can also say, according to the definition, there are some key principles. And the key principle of functional safety, and particularly in the context of new machinery regulation, encompass several crucial aspects. The machinery must be designed and constructed with safety as a paramount concern, incorporating necessary safeguards and features to prevent accidents. A thorough risk assessment is essential to identify potential hazards and ensure compliance with health and safety requirements. And the machinery must undergo rigorous testing and certification to verify that it meets established safety standards. So it's always the same. You need to do a risk assessment, and we have to reduce those risks, and we have to show in terms of testing and certification and to prove that we have done the accordingly to fulfill those requirements. And we are always talking about machinery. I will also come later on again back to those definitions. Now on go a little bit into the timeline on how functional safety evolved. Some of you may remember, at least in the European Union, we have safety requirements for long decades right now established. One of the first standards to be applied was the EN 9054, which was released in 1996. And only a few years later, we started with the development of an open safety to have a part to encourage people and to allow people to have a standard and to applying those safety requirements into their systems and machinery and alike. Around that time, also according specifications were released by IEC, the more or less well-known 61508 in the first edition, as well as the ISO 13849 in its first edition, which made some general definitions regarding safety requirements, functional safety. Shortly after, we also published CAN Open Safety as our standard, as CiA 304. And you see then in the timeline, then for a long time, for some time, nothing really happened. Until in 2006, the first EU machinery directive was published and became active. Only after that, the first specification regarding communication were released, like IEC 61785-3, which layouts the basis for functional safe communication in industrial networks. At that time, we wanted to make it, or shortly before, we want to make CAN Open Safety an international standard, but we were postponed because we needed some basis foundations, and it happened that those basis foundations were released and updated. So we see 61508 edition 2 was then released in between, 61784-3 also in edition 2 were released in between. And then we finally in 2010 were able to release an open safety as a European standard. Around in the next few years, the SAE developed for J9039 CAN Open Safety or incorporated CAN Open Safety requirements solutions, protocol definitions in the J1939 protocol, and that was then published in 2020. And now we are almost here. So the new EU regulation has been passed, has been partly active for almost 2 years now, and will become completely active in for new equipment in 2027. So what does all that timeline mean related to CAN? I want to remind you, and we heard that already partly, we have 3 generations of CAN. We have the original CAN, or as we call it, CAN CC, released in 1986. That is what we use for CAN Open, for example, or for J9039. We have CAN FD, released in 2012. For that, we have CAN Open FD, and also J9039 has a representation and a mapping on CAN FD. And just a few years back, we have now also released CAN XL in 2021. So I will now go through all the variations of CAN and what is available today, and we'll try to talk a little bit about that. So first start, here we see the three different frames, and we see mostly this general structure between those three generations of CAN remains the same, and that was a very important topic. We have a few additions made over the time, of course, with the new requirements. But now start with CAN CC and yeah, the original CAN. So what we have here is for functional safety in CAN CC. And that picture is basically taken from the original CAN open safety definition. And the idea, of course, is to have a mixed version or have different devices on the very same network so that we have a regular control solution on mixed together with the functional safety requirements and functional safety devices on the very same network. And that all using the very same pen. And what we see here is also, it is, and that is also the original idea, it is on the very same network. So we have no repeaters, we have no connected networks and so on. It's a single CAN-based network. And for that, we have, as I said, CAN Open Safety defined as a European standard, and we have the SAE J9039 safety. With a short look into the IEC definition for functional safe communication in industrial networks, IEC 61784-3, this standard lays down the fundamentals of functional safe communication in general in industrial networks, and more or less makes the definition on functional safe communication on what's called black channel. So I have certain repeaters and how all this comes together with the ISO layer. If I put CAN Open Safety in the mix, I said already, we don't do it as a black channel network. We do it as we call it as a white channel, or you may call it gray channel. Because the whole CAN Open Safety network needs to be a single network. There's no repeaters, there's no elements in between the devices that needs to communicate with each other. And if we want to make communication possible, we need safety communication which translate one safety from one safety network into another safety network, and the other one maybe, of course, an open safety, or maybe a J9039 safety, or whatever. So what were the original requirements for CAN Open Safety? The original, and that's why we say white channel, it should utilize the reliability of CAN. As we know, CAN is very reliable and robust. It should be simple in terms of implementations. And as I showed from the original timeline, we started at the end of the 1990s of the last century. And at that time, CRC calculation was very expensive. So we decided on how to, or we try to find a solution where we don't require additional CRC calculation. And of course, a small footprint should be suitable because we want to have a cheap solution. The final solution for CAN Open Safety finally was that we define the so-called safety-related data object in SRDO. And the SRDO is comprised of two CAN frames, which are transmitted in the CAN network. The first CAN frame contains our data, our original data, and it could be a message between 1 and up to 8 bytes of content. And that first message, CAN message, requires a second CAN message. And the second CAN message has some certain requirements. The first requirement is the content of the message needs to be bitwise inverted. And only if we have both messages received, then the SRDO or the functional safe data we try to transmit here is valid. And of course, we have some additional requirements because as we have to transmit two CAN messages, we need a requirement that, of course, both messages come in at a certain time. And so an additional timing requirement was added. And we see here, at first, of course, we have both messages needs to be transmitted. Of course, both messages needs to be received within a certain amount of time, what we call the safety relevant validation time. And if we don't receive a message within this timing requirement, then the SRDO is considered invalid and the functional safe function needs to be triggered internal in the device. Another requirement is that that an SRDO, or basically both CAN messages, needs to be periodically transmitted with a so-called refresh time, and the receiving side is monitoring this timing. And if the so-called safety cycle time is expired, then of course the SRDO is considered as invalid, and the safety function must be triggered. So in short, with CAN Open Safety, we have a very simple protocol. It is easy to implement because the data that needs to be transmitted needs only to be transmitted in a second CAN message, and the data is bitwise inverted. And then on top, around that, we add some timing. That, of course, is in terms of CAN Open, is needs some additional definitions in the object dictionary. In the object dictionary, we need the definitions for the SRDO. That means which CAN IDs are we using, what are the timing requirements and the like. And we also have the definitions of what data we want to transmit. So basically the SRDO mapping. But that is regular definitions, what we use in CAN Open already for years, and what we call in CAN Open normally a PDO. So the SRDO is very similar to a regular PDO. And then, of course, the mapping is, as I said, is very similar to a PDO, what we have in CAN Open. So the safety, the functional safety is really just this the few additional transmission of additional CAN message. And as I said, also the parameter definition means what CAN identifiers are we using for both messages, and what are the timing requirements on the transmitting side and on the receiving side. And with all those definitions, we fulfill all the requirements to be considered for transmitting functional safe data with the requirements of functional safety. The numbers basically where we prove that it could be used for applications up to CiA safety integrity level 3 systems. And in the past, we had also a reference design based on a 16-bit microcontroller, an old designed 16-bit microcontroller, pre-ARM Cortex, and it was also pre-certified and could be used for simple sensors and actuators. So that was for CAN Open Safety, and that is available these days and used in many applications. What about SAE J9039? And if we look at the definition of J9039, the more detailed information you can find if you follow the link in the QR code. As you see, the requirements are the same for like with CAN Open Safety. Oh, I needed to change something. And the definitions are very similar. The difference is J9039 uses a so-called safety header message, which is always an 8-byte message, which contains a sequence number, a reference to the safety data message, and an additional CLC. And then the data is then transmitted in the safety data message, which basically is a regular DGN, basically. And then in J9039, also an additional timing is added, and yeah, the timing is similar to CAN Open Safety. So as you can see, J9039 safety and CAN Open Safety are very similar. The only difference is J9039 was a little bit was developed a little bit later, and adds in the safety message, in the safety header message, CRC instead of transmitting the original data. But in a sense, it's very similar to CAN Open Safety. Now, if you take a look at the further advancement, what's about CAN-FD? If we look at a single CAN-FD network, of course, as CAN-FD can transmit CAN-CC messages, we can use the very same protocols. We can use CAN Open Safety, and we can use SAE J9039 safety, whatever is applicable for my dedicated application. But we are then here still limited in the 8-byte messages because we still need to transmit classical CAN messages in the CAN-FD network. So we cannot utilize all the new features of CAN-FD, like longer frames. And with CAN-XL in the mix, we have currently no current definition, except then, of course, I can use also my original CAN-CC message. So we have currently no dedicated definition for CAN-FD and CAN-XL, but of course I can use the CAN-CC definition. I said in 2023, the new machine regulation was released. It puts in more focus on security, and I think Olaf later on will have a general talk on security. What we need to integrate is to CAN Open FD, maybe, and we are currently also working on an outlook and what CAN Open Safety is doing with CAN Open FD, but that needs to review. Do we want to stick with the white channel approach, which has the features or the advances to utilize the features of the underlying communication, which allows simpler device implementation, but is prohibitive in using routers, gateways, and the like? Or do we want to move to a black channel approach, which allows us to use end-to-end communication and don't care about routers, gateways, or whatever, but of course will make the implementation much more complicated. I want only highlight a few differences between the machinery directive, the original directive from 2006, versus the current regulation. The most obvious change is the regulation becomes immediately active, while the directive needs to be translated into national laws in the EU, the regulation does not require national laws and becomes immediately effective in all EU member states. The main innovations and changes are the coverage of new risk associated with digital technologies, especially AI technologies, that I would say in terms of CAN-based communication, it's not something we are concerned with too much. It needs a reassessment of high-risk machines. So it's more a formal requirement and not a change in the communication definitions. And another one is a reduction of paper-based documentation. So all the documentation needs to be digital in the future. What's also included is advances into new types of machineries like human-robot collaboration, or cobots, as it is mainly known. Machines connected to the internet. It affects software updates, and especially it also integrates autonomous machines and remote monitoring stations. So if we are talking about mobile machinery, then we know autonomous behavior also becomes apparent in mobile machines. And of course, here a special risk assessment is required for such machinery with autonomous behavior. So it is more, again, for the machinery, a burden on the machinery manufacturer to cover all those requirements. Especially attention is here. What's new in the machinery with the evolving autonomy is the risk that may arise of the machinery has been placed on the market to its evolving, and autonomous behavior must also be included. That means is what happens to my machinery, basically what we know is artificial intelligence. What happens if the behavior, because the machinery learns over time, what does it mean to the risk of my machine? And I need to cover and to do a risk assessment. What does the learning of my machine means for the risk of the machine? And I said some additional IT security requirements have arise, like especially with internet connected machinery and software update requirements. And with that, I will come back to my original slide. And with that, I want to encourage people to join our ongoing work into the functional safety in the definition of CAN Open FD, safety and ongoing safety, how to proceed, how to going on. And we have several discussions going on in our interest group 06, special interest group 01 on functional safety. And you may contact us at Secretariat CiA. And with that, I want to thank you for your attention, and yeah.